The discounted cash flow techniques, there's two of them, are the best methods to use for analyzing potential investments because they take into account the time value of money. So money received, on an investment 2, 3, 4, 5, 6 years from now is, it's not worth that amount of money today. So you can't count on huge dollar amounts coming in 5, 6 years from now as being the same value as that same amount today. So that's a present value idea. And there's two methods, the net present value method and the internal rate of return method. We're going to look at the net present value method and skip over the internal rate of return method. So in the net present value method, what you do is you look at the present value of all the future cash flows that you expect an investment to bring you. Okay, so present value of the future cash inflows, and you subtract from that the cost of the investment today. So this present value, that we're going to show you a way to calculate today's value of all the cash inflows over the years, and we're going to compare that to the cash outflow today. So you can see these dollars are both going to be in today's dollars then, cash inflows minus cash outflows. If the inflows exceed the outflows, then this method says go ahead and do it. If not, then this method will say reject the proposed idea. Okay, so the hard part obviously then is figuring out what is the present value of the future net cash inflows. And there's a couple different scenarios. One is if the cash inflows are expected to be equal in the future years. You're going to use the Appendix C tables that we talked about in Appendix C to figure this out. So if you have cash inflows of $26,000 a year for 10 periods, you find the 10 period, these are two different rates used in this example. They'd be mutually exclusive, so either one or the other would apply, but it's just showing you two different rates for sample purposes. You'd find the factor amount in the present value of an annuity table, Table 2, Appendix C, for 10 periods, 12%, and that will give you this factor, this discount factor. That amount times 26,000 gives you the present value of all of those future cash inflows. At 15%, same thing, just different factor, you would get this as a present value of the future cash inflows. So what you do then is you compare the present value of all those future cash inflows with the cost of the investment. And if the amount is positive, then this method says go ahead and do it. If it's negative, then you shouldn't. The only difference really for unequal cash inflows is that you can't use the annuity table. You have to look at each cash inflow, expected cash inflow, year by year, and come up with the present value for each one of those years using the present value of one amount, Table 1 in Appendix C. So a year from now you expect to get $36,000 from this investment. What's that worth today? Well, at 12%, 1 year, 1 period, this is the factor. So this 36 times this factor gives you 32,143. That's the present value of a $36,000 cash inflow a year from now. So you do that for all of these cash inflows, and you add up all the present values, and you can see you have a present value now of all the unequal future cash inflows. Here's the 12% example. This is the 15% example. And again, you compare those present value amounts to the investment amount. If it's positive, this method says it's an acceptable investment. If it's negative, this method would say it's unacceptable. That's not to say it's a guarantee you should go do it, because there's other things to consider. This is just a financial analysis that gives you some initial data. But it is better than any method that doesn't take into account the cash flow of money or present value situations. Again, this could be complicated. Email me with copy-pasted questions from homework if you have any questions, and we'll see if I can get you straightened out.